This section is going to be about recovery. Short-term recovery, sometimes called active recovery, occurs in the hours immediately after intense exercise. Active recovery refers to engaging in low-intensity exercise after workouts during both of the cool-down phase immediately after a hard effort or workout, as well as during the days following the workout. There are many things that are achieved during recovery. Some of these include the resynthesizing ATP-PC stores, the resaturation of hemoglobin and myoglobin. All of these things are during the alactic phase of recovery. There is a slower phase called the lactacid phase. During the lactacid phase, it will try to remove CO2, remove lactic acid, and try to replenish muscle glycogen stores. This will be a lot longer than the uh, alactic phase. During the alactic phase, since it is doing a lot more complicated processes, you will recover differently from how intense the activity you did was. For example, if you walked for an hour, you will recover very quickly. However, if you took part in a triathlon or a marathon, the recovery process will be a lot longer since the exercise is a lot harder. If you played in a match with breaks in it, around 10-minute breaks roughly, you will probably be able to recover during the match rather than the end of a match. There are 4 stages of recovery. The ATP-PC stores replenish, lactic acid is removed, and myoglobin is replenished, and the glycogen stores are replenished. As you can see in figure 1, there are 2 different activities. One is steady state exercise and the other one is maximal. The graph on the left is steady state exercise and it shows there is quite a big oxygen deficit. However, on the other graph to the right, the maximal activity, the oxygen deficit is huge compared to the steady state exercise one. The epoch is different as well. The epoch for steady state exercise is quicker and smaller than the maximal activity. What is interesting about the maximal activity, which is a lot quicker in time and it has a longer recovery time. This might be because the fact that they're reaching their VO2 max rather than meeting the demand for it. The demand you can see is a huge difference in maximal activity compared to the steady state exercise where the person is meeting the demand rather than the VO2 max. There are 2 different parts to the recovery process. One is called the alactic process and the other one is called the lactacid. The alactic process is a faster process lasting around 2 to 3 minutes. This is where ATP is resynthesized. The PC stores are also restored as well. Myoglobin is also resaturated too, as well as the hemoglobin. Both of these are myoglobin and hemoglobin are resaturated with oxygen. The aerobic system produces energy to resynthesize ATP and PC stores. This will use around 3 to 4 liters of oxygen. 50% of the PC is restored in 30 seconds, and it will take approximately 3 minutes to get to 100%. You can see the rate of the PC stores replenishment on the top right of your screen. In addition, there is a graph to the top left which shows how if you don't leave adequate recovery time, the stores don't have enough time to fully replenish, meaning when you start the next bout of exercise, you will have less and less, meaning your performance will worsen and worsen. The lactacid section is a slower, longer part of the recovery process, lasting anywhere between a couple of minutes to many hours. There are 3 main things that will happen during this process. These are the removal of CO2, the removal of oxidized lactic acid, and the replenishment of muscle glycogen stores. The replenishment of muscle glycogen stores will take a lot longer, around 2 hours to a couple of days. If there is an increased cardiac output and ventilation, this could help remove the amount of CO2 in the body. I've decided to go into the lactacid phase more in depth in here, since there wasn't enough room on the slide I just talked about for the other graphs and stuff. I talked about how the lactacid phase is a slower recovery. There are three main things: the removal of CO2, removal of lactic acid, and the replenishment of muscle glycogen stores. You can see the muscle glycogen stores replenishment in the bottom right graph, where it will take about two days to fully restore all the muscle glycogen stores. A short duration, high intensity exercise, or a moderate intensity, moderate duration exercise, that will be 800 meters or 100 meters. The restoration can take up to 2 hours. Prolonged low intensity aerobic exercise, like the steady state exercise, like a triathlon, this can take days to fully restore. However, a high carbohydrate diet can speed up the glycogen recovery process. Here are some ways of increasing the carbohydrates in your body. Muscle cells are most receptive to carbohydrate during the first 2 hours following a training session. To accelerate recovery, consume around 400 to 500 calories of carbohydrate shortly after the training session, and another 300 to 400 calories of carbs within 2 hours. An example would be a high carbohydrate loaded drink immediately after exercise. If there is an increased cardiac output and ventilation, this could help remove CO2 that's in the body. You can see in the graph in the bottom left corner how long it will take on average to fully replenish the O2 debt. As time goes on, the lactic acid can turn into five things with the help of oxygen. 65% of it of lactic acid is converted into pyruvate, 5% is converted into glucose, 20% into glycogen, and 10% into protein. The Cori cycle is where lactate travels from the liver, where it will turn into all the products above. The glucose will then be sent back from the liver to the muscle, where it will be used for energy. What is meant by metabolic needs? Well, the extra VO2 consumed after exercise by organs such as your heart and muscles, like the respiratory muscles. Your heart muscle needs oxygen to sustain an elevated heart rate and stroke volume. Respiratory muscles also require an additional amount of oxygen to maintain an elevated breathing rate and tidal volume. During the metabolic needs, there will be many things that will be restored. For example, your cardiac output, heart rate and stroke volume, back to resting levels. The breathing rate and tidal volume will also go back to the resting levels. This is the same for the temperature. You can see what order the things are done in on the right hand side of the graph, the stage and when they are done. You can see on the left hand side how long it takes for the temperature to actually return to resting levels. From the end of exercise, it usually takes around 2 hours to return to the resting level for temperature. For the application to sport events, for the high intensity low duration 100 meters, they'll be using their ATP-PC system, since it only lasts for 10 seconds. The maximal intensity graph on the right hand side, you can see that there's a very, very, very high oxygen consumption, meaning that the O2 deficit is a lot larger. It is more of aerobic respiration rather than anaerobic, which will mean that there is a lot of lactic acid buildup. The reason why the epoch stage is longer or larger is because there is a larger amount of VO2 that is needed to be consumed in the recovery stage. This is why the epoch is larger and the recovery is slower. A 400 sprint moderate intensity, moderate duration activity would be a rough mix between a large VO2 consumed as well as quite a short recovery. Shorter than the maximal one, but longer than the steady state exercise one. The main system would be the lactic acid system, since it lasts for around 50 to 1 minute, 50 seconds to 1 minute. So, and not enough time for the aerobic system to be able to actually engage. For the steady state exercise or a low intensity, high duration activity, that will mainly use the aerobic system, since the activity would last for over 2 hours. The activity that will resemble this is a triathlon. You can see that the O2 deficit is a lot lower, since you are using the amount needed for exercise, not your VO2 max. The exercise is steady state, which means that this is mostly aerobic, meaning less lactic acid buildup. This will also mean that the recovery would be a lot quicker, since less VO2 is consumed. There are many things that can occur during an active cooldown. For example, DOMS would occur, as well as the skeletal muscle pump, helping the body return blood back to the heart. DOMS stand for delayed onset muscle soreness. DOMS is the pain and stiffness felt in muscles several hours to days after strenuous exercise. The soreness is felt most strongly 24 to 72 hours after the exercise. During an active cooldown, there are many things that would happen to return your body to a resting level, or or homeostasis. These are to prevent DOMS, remove CO2 and lactic acid. It will flush capillaries with oxygenated blood, and it will continue the metabolic processes. The rate of how lactate is removed depends on how intense or severe the exercise you are doing. For example, it would take a very short amount of time to remove lactate from a walk, rather than a 90-minute football match where it would take quite a long time. It can also depend on whether the person is performing with rest during recovery phase, or will do some light exercise. This is called a passive recovery. This is because you aren't doing any exercise, whereas the light exercise, you'll be active recovery, since you're making sure you'll be active. The main reason it is called active recovery. There are many other strategies to help, such as cryotherapy and massages. This will help with the recovery process as well. In cryotherapy, a broad word for a lot of things to do with ice. For example, ice packs and ice baths will be a good example of cryotherapy. Other things include vapor cooler sprays and ice immersion. There are many benefits to cryotherapy. For example, there are many benefits to cryotherapy. It would lead to some of these benefits are vasoconstriction of the arterioles. It will decrease the tissue metabolism and decrease the pain and spasms. You can see the effects of cryotherapy on the bottom right graph, where this is where there is a control group and a cooling group. The control group is a black dotted line, which shows if you don't cool before an event, your temperature will fluctuate, and it will take longer for you to actually fully recover. If you did cool, your temperature will stay lower at a constant level throughout, and the recovery is shorter. The other way is through massages. Deep tissue muscles will be the most effective, since deep tissue muscle massages improve blood flow to muscles by stimulating the circulatory system, like the skeletal muscle pump. It will increase the amount of oxygen-rich blood, which can essentially flush out all of the byproducts like lactic acid, and it will deliver fresh nutrients. Thank you for listening. Bye.